guys, now let's look at this question together. Please don't forget to hit the subscribe button and the notification bell so that every time I post a video you'll be notified. All right, now let's start by reading the statement together. A ball of mass 0.5 kilogram is projected vertically downwards towards the ground from a height of 1.8 meters at a velocity of 2 meters per second. And then the position time graph for the motion of the ball is shown below. So this is the graph of the position versus time. Please guys, before you go straight to the questions, make sure that you understand the statement, what has been given in the statement, and then you also analyze the diagram. What is it that you need to calculate? In fact, you check all the information that that is given. All right, don't rush to the questions. All right, if now you're gonna have that tendency to skip the diagram and rush to the questions to answer the questions, I'm gonna show you that you're gonna go back to that diagram with 0.00% mood. Right? Yes, make sure that you don't do that. In projectile motion, you have to understand the statement first and you analyze the diagram before you attempt the question. All right, now let's try to understand, to analyze here. Now they are saying here there is a ball here that is being projected vertically downwards from this height over here, from this point here, so to the ground, of course, to this part here. Now guys, I want us to break these motions here. The first one, the first bounce, and the second bounce, and as well as the third one. All right, so that we're gonna try to see what is it that we know for each bounce. All right, so yeah, they are saying there's height here, so we've got something like, let me just right, so this is the first part. And then now in the first part, the ball here is being projected vertically downwards. So this is the motion of the ball. So this is the ball. All right. Let me just clicking something here. Okay. This is the ball here, downwards. So the ball is being projected. Okay. This is the height. Maybe it's the height of a building, but they didn't say that. But I just want to have a picture, guys, of what is going on here. Right. So that means now the height here, it is 1.8. So from above there to the ground. And then the second part is that we've got another height here, which is, and then this one here, it is what, 0.9 meters. And then now this ball here is gonna bounce from this portion after. Let me just clear this part a little bit. I just want some space here. All right, okay, that's great. So this ball here is gonna be in contact with the surface just for a couple of seconds, and then the ball will be bouncing and then often is going up again. All right, to reach this height. So this is the ball, and this is the maximum height. All right, that is going to be reached by the ball, and the ball will be back to the ground again. Okay, so this is the ground again, and then let's also throw the last one. Okay, so this is 0.5. so that means the ball again will be in contact, and then after that, and then the ball will start to bounce and going up. This is the maximum height again, right, and back to the ground. Okay, So this is the motion of the ball. Now we need to and then we need to analyze for the first part. So the ball here is being projected vertically downwards, so that means the initial velocity is 2 meters per second. And then what else do we know here? Just from this point here up to the ground over here. So we do have G here, 9.8, it is constant. And then what else do we know? Oh, this is the height. We also do have the height here, but we do not have time, delta t, which we don't know at this point in time. So this is the information that we have for the first motion, or for the first bounce. All right, then now let's begin to attempt the first question. So we're gonna go over and over analyzing from this point in up to the last one as we go through the questions. All right, then the first question now says, what is the maximum height what is the vertical height reached by the ball after the second bounce? So this is the first one and this is the second one. So this is the first bounce and this is the second bounce. So what is the height here? Of course, the height here, it is 0.5 meters. So that means to answer the question in 3.1, so for the height there, that is h is equal to 0.5 meters. That is the first question. Now we go to 3.2. Calculate the magnitude of the time t1 indicated on the graph. Now we need to get the time t1, that is the time from here up to the ground over here. So remember guys, we need to choose a direction first. Just before we do anything here, we need to choose a direction. Now we can choose downwards as positive, or we can choose upwards as positive, but I would like to choose upwards as positive. Okay, and then just before I go far, I want to write down the equations of motions over here, so that we are going to choose the one that is suitable for this information. Okay, so let me just write them over here. So that is the first one over here. Right, so these are the equations of motions. So now we're going to choose the one that we think it is more suitable according to the information that we have for that particular question. Now I want us to calculate the time t1, that is the time when the ball hits the ground from this point over here up to this portion. So we want to know what is the time over here to the ground. That is time at t1. It's for 5 marks. So now what I'm going to do here is that we cannot use this one, the first one, because this one requires to substitute the final velocity, which we do not have at this point in time, and as well as this one. In fact, this one doesn't have time at all, so that means we can use the third equation. So we cannot use this one, we cannot use this one for now. So I want us to take the first equation first, sorry, the third equation, and then we see that how do we go about solving time then. So we can take the third one, because we do have height, which is 1.8, we do have initial, which is 2, and we're looking for time. All right, so that means that one, it is the right equation. And then we just write it here. Let me just stop over here, just in some little space here. Okay, so yeah, that means you first have to write down the data, just to collect the information that has been given. So we have initial velocity, which is 2 meters per second, and we do have a height, which is 1.8 meters, and we do have g, which is 9.8 meters per second squared. And then we we are looking for time, which is t, we don't know. And then we said we're going to use the third equation, delta y. Yes, this is the equation that we're going to use. Then I will begin to substitute. Just before we substitute, I want us to consider the fact that if we have chosen upwards as positive, so that means 9.8 will be negative, and as well as the height, because right now the ball is going down, so that means the delta y 9.8 will be negative as well. And there's also that 2 meters per second, because it's also going down, so will be negative as well. So these are the things that I wanted us to take a note of just before we start. Now I'm going to substitute with the height in the place of delta y here and the initial velocity, and then we solve for time. Perfect. This is our substitution. Then we just work it out, and then we go to the quadratic equation, because there will be no factors here. Okay, so now we're gonna take this one, then we equate to 0, and then that means we're gonna have negative 4,9 delta t squared, and negative 2 delta t, and then we're gonna have plus 1.8. we're gonna just transpose this one to the side, and then we note that, okay, the value of a it is negative 4,9, and the value of b it is negative 2. Oh, sorry, just before we go that we need to divide each term with a negative sign, so we're going to divide in all, so negative 1, negative 1, then we're gonna have 0, which is 4.9 delta t squared, and then plus 2 delta t, negative 1.8. Then we say the value of a it is 4.9, and b it is 2, and then c it is negative 1.8. And then we go straight to the quadratic equation. So this is the quadratic equation. Now remember, this one represents the value of b, and a, and c. So the value of a it is 4.9. So now we need to press this one in our calculator, and then let's just check that how do we go about working out this one in a calculator. So you press this button first. You start by pressing button fraction, and then this the root, and then take this menu out. So we're gonna have minus 2 and then plus, and then you come in there, negative 2, sorry, must be 2 squared, and then minus 4 times 9.8, and then just negative 1.8, and then you go down, must be 2 times 4.9, and then that means must be 0.44. all right, so this is our time, so this must be 0.44, so that means delta t it is 0.44 seconds. Don't forget that we are solving for time, not x. Okay, let's just confirm the second one. Let's just confirm the second one here. So that means we're gonna have let's just check if maybe we can just change in the place of plus there, and then we're gonna just put minus. Yes, let's just remove that plus and put minus. So it is negative, so we cannot take negative, guys. Why? Because time it is a scalar quantity, so it doesn't have direction. So let's just erase this part here. So the only value of time that we got here, which is 0.44 seconds. All right. Also, guys, if you want, you can even use that is the second equation, and as well as the first one. So if you want, you can use this equation over here just to get the final velocity first, and then after that you use the first one, you substitute with that final velocity here, and then to get time. So I'm going to show you the time is going to be the same, so we can also give a try that one just to confirm this answer. Let me just say or, so we can use the second one, vf squared is equal to vi squared. Yeah, so this is the equation. Then we just substitute. So here we are solving for VF, that is the magnitude of the final velocity here. So we'll be substituting, remember, the value of initial velocity is -2, and then which is substitute throughout. This is the substitution, and then this is -9.8, and then we just work it out. So this one, and then we see that what is that we have here. So that means it's gonna be let's just check now. If now we're gonna just work this one and then our calculator, -2 all squared, and then must be plus 2 times -9.8 and -1.8. Okay, so that is must be 39.28. So must be 39.28. So must be 39 must be 39.28. And then remember, here we're still having VF squared, so we just square root in both sides. So this will nullify, therefore VF must be equal to, let's also confirm that what will be the value then. If now we say 39 point, must be 39 point, let me just go back there just to confirm, it's 39.28, right? It's 39.28. So the time is 6,27. Well, that's perfect. So it's 6,27. So the time is 6,27 meters per second. But remember, guys, we have chosen here the direction. We have chosen upwards as positive, and this ball is going down. This ball is going down. So that means this final velocity will be negative because it's actually opposing the direction. So that means this one is going to be a negative because of the direction. And then now we begin to use the first one equation. So this is the first equation, then we just substitute. So the final velocity is -2.7, and the initial is -2, and -9.8 delta t, and then we just take 2 on those sides. So we're gonna have -2.7 plus 2 is equal to -9.8 delta t. We just divide both sides by -9.8, and this one, therefore delta t. Maybe we can just confirm this from the calculator, otherwise this is not a big problem. So 6.27 and then plus 2 divided by -9.8. The time is 0,44 seconds. All right, so that means, so it is the same. So I've just got that 0,44 seconds. So this is the time for 3.2. Right, now let's move on to the next question. Now the next question here says velocity with which the ball rebounds from the ground during the first bounce. So that means here, what are we looking for here exactly? We are looking for, that is the velocity. Let me just try to clear this part a little bit. We're gonna see, I just want to see what's going on here exactly. So now we want to see the initial velocity here. What will be the initial velocity during the first bounce? And then we know that at maximum here, the final velocity will be 0. So we do have the height. So we want to know what is the initial velocity here. What is the initial here? So that means in this question, so in order for us to get the initial velocity, so we can use out of the equation of motion, we can use the second one, because for now we do not have time from here, from this point up to this point here. So what we know, it is this is the final, the height, and 9.8, and we're looking for initial. So therefore the second equation will be the right one to use in 3.3. So let's use that one exactly. All right, so that is number 3 points. Sorry, I'm continuing with blue. 3.3. So now let's use the second one. VF squared is equal to, perfect. Then after that, my V's look like R here. You know, sometimes my handwriting, yeah. and then we substitute. Remember, we're looking for VI because VF is 0 at maximum, and then we do have 9.8 as well as the height. All right, now let's go over and substitute. Perfect, this is our substitution. Then now the height here cannot be 0 now in this case. Why? Because the height cannot be negative. Why? Because the ball now is going up. We want to know when the ball is going up, and we have chosen upwards as positive. So that means the height there is going to be the same direction as the main one. So here we just transpose this number to that side, and then we're gonna have VI squared is equal to 2 times 9.8. That must be 9.8 and 0.9. So remember, this must be positive because it's been transposed to that side. And then we just work this one out using our calculator. So we check that if we have 2 times 9.8 and 0.9, and what is the 17.64? That is the answer, 17.64. So we've got 17.64, and here we've got VI squared. Remember, we never have to square root in both sides. So after that, that means V initial must be, we just work this one out from the calculator. That is square root of 17.64. It is 4.2. So that means the answer is must be 4.2 meters per second. This is the initial velocity. Remember, this one should be positive because it is going the same direction. We can also indicate that one that it is upwards. All right, so the direction it is upwards. Okay, that's great. And then from this point over here, then we can just go straight to the next question. All right, so our question now says the ball is in contact with the ground for 0.2 seconds during the first bounce. I want you to note that that is the ball here is being with the contact with the ground for 0.2, and then now they say calculate the magnitude of the force exerted by the ground on the ball during the first bounce if the ball strikes the ground at. So this answer actually confirms the one that we have already calculated, the final velocity from that height of 1.8 to the ground. Remember, we've just got 6.27, so that means our answer is 100% correct. All right, so now we want to know what will be the force exerted by the ground on the ball. Okay, so that means now in this case we're going to borrow that formula from momentum, the one that says must be 3 point for this question, that is force F net times delta T is equal to the change in momentum. We need to borrow this one because, why am I saying that? Because from the statement here we are given what the mass here, and then also we do have the initial velocity as well as the final velocity. This is the final velocity, so that means we can use this equation over here, right? Sorry. So now let's just make F net subject of the formula. All right, so it's going to be F net must be equal to, remember, change in momentum is going to be mass over, that is VF minus VI, and then divided by time, which is delta T, and then we just substitute. Remember, the mass is 0.5, and then remember the final velocity there, it should be that is 4.2, and then a minus into negative 6.27. all right, and then we just press this one in the calculator, and then we're gonna get that is 26.175 newtons. So this is the force that is being exerted by the ground on the ball during the first bounce. Now we want to know, now let's go straight to the last question. Now in the last question they say draw a velocity time graph for the motion of the ball from the time that it is projected to the time when it rebounds to the height of 0.9. Okay, that means we want to know from here and then up to this portion, only this part. All right, this is what we want to know for now. Okay, then now they say clearly show the following on your graph. So in our graph we need to show the following values. So the following values we need to show, that is the time when the ball hits the ground. So we need to show that time. What was the time when the ball hits the ground? Remember the time we've just got 0.44 seconds, and then also we need to show the velocity of the ball when it hits the ground. Remember that velocity of the ball when it hits the ground, we've just got 6.27. we need to show that. And then also the velocity of the ball when it rebounds from the ground. Remember we've just got 4.2 meters per second. Therefore we need to show those three things in our graph, 1, 2 and 3 in our graph. For how many marks? For 3 marks. Now let's go and sketch the graph. All right, let's go and sketch. All right, now let's indicate these values here in our graph. So we've got -2 somewhere here, and we've got -6 somewhere there. Okay, and then up there we're gonna have 4.2. Remember guys, the graph of velocity versus time is gonna give you let me just try to clear this view here. That's perfect, wonderful. Remember the graph of velocity versus time is going to give you acceleration. Now we have chosen upwards as positive. That means acceleration is going to be negative. Therefore the slope is going to be like this. Okay, so it's going to decrease. All right, so that means we're going to start. Remember the initial velocity is 2, so you cannot start from 0 guys, no, because the ball is projected. So that means we're going to start from -2, but we need to indicate the time. That is 0.44 seconds to the ground. And then we also need to add the time when the ball was in contact with the ground for 0.2. That means that 0.44 to the ground plus 0.2. The contact with the ground is going to give us, that is 0.64. So that means this is the time here. So that means must be 0.64. All right. So we need to show that time here. And then now we start to sketch. So when we draw, so that our graph will be drawn like this one. Perfect. Then that's when the graph hits the ground here. So remember this is 2.7. Perfect. So then after that the ball rebounds. So this time over here is that time, which is that 0.2 when the ball was in contact with the ground. So we just take it up. So if not the ball has bounced, we need to show with the dotted lines. Okay, perfect. Then this is the time, and then up to that initial velocity there. So remember there's that initial velocity, and then now the ball will become, and then to rest. Okay, so this is the graph that represents the motion of the ball. All right, I hope guys this is clear. But if is there any question that you do not understand, let me know it from the comment. Thank you so much. Then now we can just erase this part. So that's all, guys. Thank you so much.